Hi, in this video we'll be finding the volume and the surface area of the 3D shape that you see here. And now if you take a look at this shape, it is such a great shape to work with. It looks like a pencil. And so imagine a pencil. Here we have a cylindrical part, here we have half a sphere, and here we have a cone. All right, so we're going to jump in and we're going to start by finding the volume. So in order to find the volume, we do need to find the volume of all three shapes that we see and add them up. So here is a hemisphere, half a sphere. And so let's write that down. And the volume of a sphere formula, if you look that up, is 4 over 3 pi r cubed. All right, but this is not a whole sphere, it's a hemisphere. So half of 4 over 3 is 2 over 3. So the volume of a hemisphere is equal to 2 over 3 pi r cubed. So we're going to need that. And now for our cylinder, the volume of a cylinder formula, let's write that down, is pi r squared times h. And finally, we have a cone, and the volume of a cone formula is 1/3 pi r squared times h. All right, so we have three things there. All we need to do is find the volume of each of those things and add them up. Now, there is a tricky piece to this. So for our cone, we actually don't have the height. We do have this value, which is our slant length, which we will need later, but we need our height in order to find the volume of the cone. That doesn't mean that we're stuck. What that does mean is that we can visualize a triangle. So here we have the hypotenuse of the triangle. And if I go that way to the middle of the cone, that is a leg of a triangle. And this is what we're looking for, the height of the triangle. So what we just did is created a right triangle inside the cone. Now with that right triangle, as with any right triangle, if you have two sides and you're looking for the third side, and I'm going to draw it off to the side here so we can see it better. All we need to find the third side is Pythagorean theorem. So we have the 1.5 here, and we want the height here. We actually also have this length here. So if you look up here, the whole diameter of our sphere is 0.8, which means that the radius of our sphere is 0.4. And down here, it's also 0.4. So let's label that 0.4, 0.4. Okay, so here we have our right triangle. We have two sides. We're looking for the third side. And the Pythagorean theorem states that a squared plus b squared is equal to c squared, where c is the hypotenuse. So now we can finish that by saying 0.4 squared plus h squared equals, or hypotenuse, 1.5 squared. Now in order to solve for h, we can subtract 0.4 squared from both sides. And so we get that h squared is equal to 1.5 squared minus 0.4 squared. All right, so now we can calculate what h is. So let's do that. 1.5 squared minus 0.4 squared is equal to 2.09. So h squared is equal to 2.09. And in order to find what h is, we just have to square root that. So second, and then square root 2.09. And we get that h is 1.45. All right, so that is the height that we need. I'm going to replace h with 1.45. And now we can start working with our three formulas. So in purple, first of all, we are going to use our volume of our hemisphere formula to find the first part. So let's move that over here. Give ourselves more room. Okay, so volume equals 2 over 3 pi r cubed. And we spoke about what r is before, but let's talk about it again. Here we have the middle, and our radius is half of that, so it's 0.4. And so it's 2 over 3 pi 0.4 cube. And we'll calculate that in just a second. All right, and so now moving on to our cylinder, the volume is equal to pi r squared times h, which is pi, and our radius, as we know, is 0.4 squared, and the height of the cylinder, and the height of the cylinder is 14, so we can put that in here. That's our h, and we'll calculate what that is in just a second. And finally, our cone, 1/3 pi r squared times h, so that part here in pink, volume of the cone is 1/3 pi r squared times h, and we have a different h here. That's the h we just calculated. It's 1/3 pi 0.4 squared, and as you may recall, our height of our cone is 1.45. And now we can calculate all the pieces. So let's do that together. And first the purple for the hemisphere. So we open up our parentheses to put our fraction in. So we have 2 divided by 3. We close that parenthesis, and we have second pi, and then r, which is 0.4, raised to the third power, and we enter. And so for the top part, or hemisphere, we have that the volume is equal to 0.134 centimeter cube. All right, let me, good habit to write that in, centimeter cube. Okay, and so now for the orange, which is our cylinder, I will put that in as second pi times 0.4 squared times 14. And when we enter that, we get that the volume of our cylinder is 7.037. 7.037 centimeter cube. And finally, for our pencil, pink part, we will type in 1/3. Let's shift that there. Okay. 1/3. Close that parenthesis. Pi 0.4 squared times 1.45, and that's the height that we calculated on the cone. And we get 0.243 approximately. And that's centimeter cube as well. All right, so now we have our 3 volumes for the 3 shapes, the hemisphere, the cylinder, and the cone. And all we have to do is add those up. So 0.134 plus 7.037 plus 0.243, and our overall volume is equal to that value. So our volume is equal to 7.414. Oops, wrote that backwards. There we go. 414 centimeter cube. All right, so that is how we find the volume of this composite figure. Finding the surface area of the figure is going to be slightly easier because we already have our slant height, so we don't have to do Pythagorean theorem in the middle of the question. All right, but we're going to go ahead and approach everything in a very similar way by breaking down the figure into its parts. And so the first shape, let's go back to purple, hemisphere once again. The surface area of a sphere is 4 pi r squared, and the surface area of half a sphere is 2 pi r squared. All right, and here we have, let's use the same color we used before. All right, or cylinder, the surface area of a cylinder is 2 pi r h. And that is just the curved part of the cylinder. So think of a toilet paper roll. That's just that toilet paper roll part. It does not include a top. It does not include a bottom. And we do not have to include a top and a bottom here because there is no top and bottom on the surface. We have instead a half a sphere and a cone. So there is no circle on top. There is no circle on the bottom. So this is sufficient for the surface area of our cylinder. And finally, for our cone, the formula there is surface area of a cone equals pi r L. All right, so now with all of that here, we can start calculating what we have. We're just going to stick everything that we need into these formulas. So surface area, SA for surface area equals, and I'm going to just go straight across, 2 pi r squared, so that is our hemisphere, plus 2 pi r h, that is our cylinder, plus pi r L. All right, so now we can go ahead and plug into these formulas. 2 pi, we know from before that our radius is 0.4. All right, plus 2 pi, or radius, still 0.4, and our height of our cylinder is 14. And then for our cone, pi, or radius, is 0.4. And remember that L is our slant length, and that's the length that was given to us, and that's 1.5. So we can go ahead, put that in. And we can actually just type this all into the calculator. And so I did want to show you a different approach of being able to go through this question faster than we did for volume. And so let's go ahead and do that. 2 pi 0.4 squared plus 2 pi 0.4 times 14 plus pi 0.4 times 1.5. And now that was a lot to type, so you want to check for accuracy. You want to make sure that you actually typed everything correctly. And so I'm doing a quick check here. Please do the same on your own work. And everything looks good, and we can press enter. And we now have the surface area of our figure. And so our surface area is 38.076, and its area, so that is centimeter squared. All right, so now we have our volume and our surface area of our wonderful pencil, and you're done.